welcome. We are broadcasting live from the Astrophysical Observatory of Halavambre, Teruel, Spain. We are located almost 2,000 meters above sea level. This is one of Spain's leading astronomical observatories, located directly on the path of totality for the total solar eclipse tonight. A path that crosses Greenland, Iceland, and North Spain, making it one of Europe's most significant astronomical events in decades. Hello. My name is Dame Dr. Maggie Adarin, and I'm a space scientist, a science communicator, a broadcaster, and an author. And I am incredibly excited to be here tonight. But I'm even more excited because of my company. So this is Carol Mundell, and she is the head of science at ESA. Wonderful to be here.
Thank you for joining us at this wonderful event, Maggie, and for hosting it for us. We're very excited, and obviously to be at this beautiful and special location.
It is fantastic here, and the view is gorgeous, and the skies are clear.
They are clear. We've been watching them all day. We've been preparing for the event, and we've been watching the clouds clear. So we're really grateful to the observatory for hosting us, supporting this event. And I know you and I are going to share a very special experience, and with all of our viewers internationally, worldwide.
Yes. Now, Carol, this might be surprising, but this is your first total solar eclipse.
I'm afraid it is. So surprising it may be. But yes, it's really special. And I know it's not your first, Maggie. And so I'm going to learn from you. And we're going to give our viewers some tips as to how safely to observe a solar eclipse. And I think as the solar eclipse reaches us here, we will have just over a minute to have a quiet moment towards the end of the programme for us both to share and just experience that moment.
Yes, I'm really looking forward to it, that moment of contemplation.
Absolutely.
Because there's been such a build-up, and so we can enjoy it together.
Yes.
Now, the total solar eclipse will actually happen here at the observatory at 20:32 and 21 seconds. So we must be ready for that.
We will.
But as well as being here at the observatory, we have two live feeds also coming in. Now, the first is in Lyon, and people there have been gathering all day. I think you said there were 3,000 people for an Easter event this morning.
This morning we had a workshop, and actually the organisers are still counting, but the first count was 8,000, and we think possibly 10,000. Yes. And so you can imagine there'll be even more this evening for the eclipse itself.
These eclipses, they really draw people in.
They really do, and I know that everywhere, partial or total, there are people trying to experiencing this.
And that live feed was set up by CESA, which is a European Space Agency education programme, which brings teachers, students all together to bring space science into our classrooms. But that's not the only live feed we have, because we're quite bougie.
We are, so we're very fortunate to have a second live feed from Fromista in Palencia, and that's being brought to us by the Institute of Astrophysics in Andalusia, and also the Stars for All Foundation and the Complutense University of Madrid, whose work really focuses on the study and the protection of the night sky.
Yes. Now, at both these places, we also have sort of live video feeds. So in Lyon, we can see the people, but this is the actual view from Palencia. And I think we can just make out a small nibble there. Yes. So the total solar eclipse is actually started.
It's exciting. It's already on its way.
Yes.
Yeah.
And it looks like a sort of small nibble. And this is the live view from Lyon. Again, a small nibble. But what I love is that the path of totality, I think it's about 300 kilometres wide.
It's not very wide at all.
No,
yeah.
but we're going to actually watch it as it works its way through.
That's right, in real time, absolutely.
I know, it's fantastic. Okay, now, many people are going to be going outside and hopefully watching the total solar eclipse. But what we want you to do is to do it safely. So we have a few safety tips I think we want to give everybody so they can do it.
Absolutely.
So I think, firstly, never look directly at the sun. The sun is, even when it's low in the sky like this, the sun can cause serious damage to your eyes. So if you're going to look at the total solar eclipse, use a certified eclipse glasses. Yeah, thank you.
And we're already well prepared here. Yeah, absolutely.
So yeah, check for the certification. So you need to make sure that they are certified. Be aware, sunglasses will not block out enough sunlight. So make sure you have a set of safety solar eclipse spectacles. So during partial totality, so during the partial phase, you must wear the glasses, because even when the sun is just a thin crescent, it still has enough light to damage your eyes. So be aware of that. If you are lucky enough to be in the path of totality, once the moon has gone completely in front of the sun, then take off your glasses and enjoy the spectacle of the total eclipse. But then as the moon moves on, when you get the first rays of sunlight coming through, put the safety glasses back on, because that way you'll protect your eyes and live to see another one. Yes. And so we're talking all about eclipses. I'm very excited. As you said, this is my third one, but each one is unique. And this one especially because it's going to be very low on the horizon.
That's right, just at sunset, Maggie. So we catch it just before the sun disappears below the horizon. So I think, as you say, the two that you've seen were not at sunset.
No, they were much higher in the sky.
That's right. So when, obviously, people may have seen at the time when the full moon has been just rising, it's near the horizon, it appears to be very large. It's not larger, but it's an optical illusion. Yes. So we're hoping to see that in reverse as the moon covers the sun entirely. And as you say, we'll be observing that very safely from here.
Very safely, yes, at all three sites. So we're talking a lot about eclipses, but the question remains, what is a solar eclipse? And for that, we have a video.
What is an eclipse? At its simplest, it's a shadow. Whenever the sun, earth, and moon line up in just the right way, one world casts its shadow onto another. A simple alignment with extraordinary consequences. The sun is about 400 times wider than the moon, but it's also 400 times farther away. From Earth, they appear almost exactly the same size in the sky. It's this extraordinary coincidence that makes a total solar eclipse possible. A solar eclipse happens when the moon passes between Earth and the sun, casting its shadow onto Earth. But solar eclipses don't happen every month. That's because the moon's orbit is tilted by about 5 degrees. An eclipse can only happen when the moon crosses the Earth's orbital plane at just the right moment, allowing the sun, moon, and Earth to align. Solar eclipses come in 3 forms. A partial eclipse, where the moon covers only part of the sun. An annular eclipse, where a ring of sunlight remains visible around the moon. And a total solar eclipse, when the moon completely hides the sun. During a solar eclipse, the moon's shadow falls across only a small part of Earth. Most observers are in the penumbra, where only a part of the sun is covered. But within the umbra, the moon's darkest shadow, the sun is completely hidden. This narrow track is known as the path of totality. During totality, light fades, the air cools, the world shifts into twilight. Some animals begin to behave as though night has fallen. Just before totality, the last rays of sunlight stream through the valleys on the moon's surface, producing the dazzling Bailey's beads and the iconic diamond ring effect. And then totality. For a few minutes, the sun's corona is fully revealed in a way it never is under normal daylight. And then the moon continues along its orbit and sunlight returns. At its simplest, an eclipse is a shadow, but it's also a reminder that some of nature's grandest spectacles can emerge from something beautifully simple. 3 worlds moving through space, perfectly in sync.
I really love that. I really love that because a total solar eclipse, the sort of thing we're going to see tonight, is a cosmic coincidence. It just so happens that the sun and the moon extend the same size in the sky, and so one beautifully covers the other.
That's right, and I think it's very special because we talk about totality being rare, yes. And of course we get a total solar eclipse somewhere on the planet about every 18 months, but about 4/5 of the planet is covered in ocean. So unless you're on a ship or you're chasing the eclipses, it's unlikely that you will see a total eclipse. And if you do have an opportunity to see one, it will probably be about 400 years before you see it again in the same location. So
if I stayed at home, I'd have to wait 400 years each time.
That's right. So we're very lucky tonight that we're here to witness this.
Yes. And it's quite interesting because the last total eclipse seen it here in Spain was actually in the Canary Islands, and it was in 1959. And but one actually on the Iberian Peninsula, which is where we're located here, wasn't since 1912. So they've waited a long time.
Absolutely.
But the path of totality has gone through Greenland, Iceland. It comes through Iceland and then covers northern Spain. And I must admit, I am just very, very excited to be here. But also at this fantastic location. I mean, I can't think of a better place to see a total solar eclipse.
Very special indeed.
So, yes. And so, we are at this observatory, but it would be nice to find out sort of what happens here, because that shadow is travelling across the Earth at amazing speeds. It's about 2,000 kilometres per hour.
It's unimaginable, isn't it?
It
when you
is.
think of that speed, and we wouldn't be able to travel between Leon and Palencia and come to here to catch it. So it's great that we have now these digital feeds, and all of our viewers can also share the speed of that as that shadow zooms across the surface of the planet.
And also, because we have these feeds, we'll be able to see it happening in one place and then see it starting to happen in another place before it actually happens here.
That's right. It's going to build our suspense and tension, get us ready for our experience.
Yes, and when the eclipse does happen, when the total solar eclipse does happen here, it will last 1 minute and 21 seconds. So we'll have to make the most of that time.
We will.
Now, one of the things is we are at this brilliant location, and so I'd like to find out more about why this is such a great location for astronomy and about the people who actually work here. So, to find out what actually happens here on a day-by-day basis, because this is a working observatory, we are very delighted to welcome the director of this observatory, Javier Ferrandro. Sorry for my pronunciation. But you have other titles too.
Well, actually, I'm the director of CEFCA. CEFCA is the Center for the Physics of the Cosmos of Aragon, for the studies of the physics of the cosmos of Aragon. And this is a center, it's a research center in astrophysics and cosmology, and our main duty is to exploit scientifically and to manage the Javalambre Astrophysical Observatory.
I see, right.
Yeah.
That sounds fantastic. So now, this looks beautiful, and it's a great place to observe a total solar eclipse.
Yeah.
But why is it a good place for astronomy in general?
Well, it's a very good place for astronomy because of the skies. We are in a very low population density area in Spain, so the light contamination is essentially null. The skies are very dark, but it's very important that the atmosphere is also very stable, because of the regime of winds coming from an area in which essentially there is no mountains. When the air is coming, the wind is coming, reaching the observatory, essentially is completely laminar. There is no turbulence, and that makes that the seeing how well we can detect of difference to different stars, for instance,
Yes.
is great. This
Yeah.
is the reason why.
So that makes sense, because stars twinkle
Yeah.
because of atmospheric turbulence.
Exactly.
And as astronomers, we want it as calm as possible.
Exactly.
I see. And so this, because the laminar flow is very smooth,
Exactly.
we can see the stars far more beautifully.
Exactly.
Okay, so now, what sort of observatory is this? So what sort of observing do you do? What objects?
Yes, our telescopes are particularly suited for doing large-scale astronomical surveys. They are very large field of view telescope. They are very different to most telescopes in the world because we try to optimize first the image quality, but very importantly, the large field of view. So our telescopes and the instrumentation that we mount in our telescope are essentially panoramic instruments to map the universe. So we are very efficient in mapping the universe, observing very large volumes of the universe in very short time scales.
Oh, I see.
And that's what makes us very different to most of the observatories in the world.
Lovely. So yes, so seeing a lot of the universe, but very quickly, and so you can map
Yeah,
what's
exactly.
going on out there. Fantastic.
Exactly.
Thank you. Now, also, there is interesting future plans, because this is a ground-based observatory with the wonderful mirror, but you have designs, or you're working in collaboration with the European Space Agency
Yeah.
for up there.
Exactly. We are also working in the Arrakis mission. Of course, this is a fantastic mission of the European Space Agency, in which we are working here as part of the Arrakis consortium. And in particular, there is a prototype, there is a replica of the Arrakis telescope that is mounted here in Javalambre, and we have started to take the first data. Of course, the quality of the data is not as good as it will be in space. This is obvious because we still have the atmosphere here, even if it's very good, but of course it has an impact. But we have started to test how the camera works, how the telescope works, how is the data reduction, how we can calibrate. And we are progressing very well, and this is going to be very important so that when the mission is finally launched, everything is ready and is optimal.
Oh, perfect. And that makes a lot of sense because testing things when they're up in space, if something goes wrong, it's hard to fix.
Exactly.
But doing it on the ground
Exactly.
in this lovely location, it makes a lot of sense.
Exactly. This is why.
Well, it's lovely to see you collaborating with sort of the space science, and very good luck with that mission.
Thank you very much.
Thank you for joining us today.
Thank you. Good luck.
Thank you. So that was hearing about sort of what's happening actually here at this observing site. But we've been talking about the magic of the total solar eclipse, the moon going in front of the sun. And when that happens, you can see the glorious atmosphere of the sun called the corona. And we talk about the corona, but let's find out a little more about it.
The eclipse isn't hiding the sun. It's revealing the part of our nearest star that is normally hidden from view. As the moon blocks the sun's brilliant surface, a soft white halo appears around it. This is the corona, the sun's outer atmosphere. Like Earth's atmosphere, the corona surrounds the sun. But instead of air, it's made of electrically charged particles called plasma. Although it stretches millions of kilometers into space, it's normally invisible. The sun's bright surface simply outshines it. This glowing halo is far from quiet. The corona is shaped by powerful magnetic fields. It's also where the solar wind, a constant stream of charged particles, begins its journey through the solar system. When the solar wind meets Earth's giant magnetic field, it can affect satellites, astronauts, communications, navigation systems, and power grids. Despite decades of research, some of the corona's great mysteries remain unsolved. For example, you might expect that the further you move from the sun, the cooler it becomes. Instead, the opposite is true. While the sun's visible surface is about 5,500 degrees Celsius, the corona reaches more than 1 million degrees. For centuries, scientists had to wait for the fleeting moments of a total solar eclipse to study this hidden region of the sun. Today, scientists can create their own eclipses using instruments called coronagraphs, which block the light from the sun's surface, allowing us to observe the corona far beyond the few precious minutes of a natural eclipse. With coronagraphs, scientists began to see the corona continuously for the first time. They discovered it is not a gentle outer glow, but a dynamic and constantly changing environment. This is where the solar wind begins, and where powerful eruptions known as coronal mass ejections are launched into space. Missions like Solar Orbiter are helping us uncover its secrets every single day. But it's still only through total solar eclipses that we get a rare glimpse of this special part of the sun with our own eyes.
So it was lovely to hear about the corona there. And I think we might have the opportunity to go live to Lyon again, just to see what's happening there. So yes, now you can see that the partial eclipse has definitely developed. We have it's like someone's taken a large chunk out of a cookie. And so yes, this is what's happening. We are getting closer and closer to totality. And yes, at the moment we can't see the sun's corona, but when we actually get to totality, that's when it all will be revealed. Now, someone who works studying the sun's corona is Andy Toe. Now, Andy, you work on the Solar Orbiter mission for ESA. So can you tell us, when we actually get to totality, what will we see?
Yeah, we will see something very, very strange and we don't really see very often, which is called the corona, the outer atmosphere of the sun.
Yes.
So this outer atmosphere actually spans millions of kilometers outside of the solar surface, but because the light's so dim, our solar disk is actually about 1 million times brighter than the corona. So these lights are often overwhelmed by the solar disk. But today, of course, we're seeing this like nature magical moments for us to see the corona using our bare eyes.
Yes. And so we'll be able to see it. And hopefully we can see some structure and stuff like that.
Yeah.
Now, the corona is quite a complicated beast. So this is the outer atmosphere of the sun, the atmosphere of the sun.
Yeah.
But it's not as we expect.
No. There are a lot of open questions, and there's still a lot of mystery that we don't understand. Although it's the sun being our closest star, we still don't know a lot of the things about our sun. For example, in the video, we talked about coronal heating problem. What the coronal heating problem is, on the surface of the sun, we have about 5,000 degrees. If we step outside, we get to maybe 1 million, 2 million, sometimes in the extreme case, 10 million degrees.
So sorry, at the surface it's about 5,000.
Yeah.
But then as we move away, it gets hotter and hotter.
Yeah, it's incredible. It's very counterintuitive, right?
Very.
It's very different from what our daily life experience is.
Yes.
The other mystery that we're trying to solve right now, and people are actively working towards, is the solar cycle. So starting from maybe 700 years ago, we started to understand that the sun follows this 11-year solar cycle. What this means is that when the solar cycle goes into maximum, we have a lot of what's called active region. We have a lot of explosions. Some of the explosions are associated with massive blob or enormous cloud of plasma that propagates in the interplanetary space.
Yes.
So,
and some of these blobs of plasma can be the size of planet Earth, I hear.
Yeah. It's absolutely spectacular. And then, especially when flare happens, sometimes particles could travel at a fraction of the speed of light. And also, along with these enormous blob of plasma, this can create what we call space events.
Yes. Now, it's funny because as space scientists, one of the things we are paying more attention to is what we now call space weather.
Yep.
And so it's all associated with this solar wind, these charged particles streaming out into space,
Yep.
and also these coronal mass ejections hitting Earth, because they can cause sort of us challenges here on Earth.
Yeah, they can cause a lot of challenges. For example, one of the obvious challenges is as astronomers are some of the astronauts there in space, so they could harm their health. We can affect satellites, navigation system, even transportation on Earth, and sometimes in an extreme case, it can really affect power grid and shut down our power as well. Yeah, so by understanding the sun a bit more, we're trying to kind of find out what caused them, how to predict them a bit better for us to safeguard the Earth.
Yes. So how is Solar Orbiter doing that?
Solar Orbiter is doing it in a very spectacular and unique fashion. So Solar Orbiter has a few skills on their hand. One of them is a really, really high resolution camera. So it's able to capture these like really, really small scale explosions on the sun that is believed to power kind of the really hot temperature of the corona. The second skill is Solar Orbiter not only has its camera, it's also a local laboratory. So not only can it image the sun, it can also collect particles streaming from the sun to do local analysis. So it can link a process happening on the sun all the way till Solar Orbiter.
Yes.
So what I think really, really cool and really, really unique is that Solar Orbiter is starting its orbit, or its original orbit is near the equator.
Okay.
But it's starting to get to a high latitude point where its orbit is doing from flat surface to kind of inclined surface. What this means is that humankind is able to measure and even capture the particles from the pole for the first time. For example, last year, we got some really, really high resolution images of the pole, which is really, really exciting. And we started to see this really fine scale dynamics that's happening at the pole. So this is kind of the first time we can piece together evidence seen from Earth and also from kind of an inclined angle to piece out like this 3D structure of the sun to understand how the solar cycle is being driven, what is the 11-year solar cycle, what drives these space weather events.
Yes. So that seems amazing. And I love it that we are seeing sort of more of the sun than we ever have before.
Yeah.
And yes, but it helps us here on Earth by getting better predictions.
Yeah, 100%. Yeah.
Well, thank you so much, Andy. And very good luck with the mission and getting more data.
Yeah, thank you.
Thank you. Now, for centuries, scientists have been looking and using total solar eclipse to understand the sun better. But now we're moving into a new era where we actually create artificial total solar eclipses. And there is an ESA mission called Proba 3, and it's doing just that.
The sun's outer atmosphere, the corona, is usually too faint to see. For centuries, it was only visible during a total solar eclipse. But what if we didn't have to wait for the moon? What if we could create an eclipse whenever we wanted? That's exactly what ESA's Proba 3 mission is doing. Instead of relying on nature, Proba 3 creates its own eclipses in space. Not with one spacecraft, but with two. Flying 150 meters apart, one spacecraft acts as an artificial moon, blocking the sun's bright disk. Meanwhile, the other observes the corona around it. The result is remarkably similar to a natural total eclipse, but with one crucial difference. A natural eclipse lasts at most a few minutes. Proba 3 can observe the corona for much longer. But creating an artificial eclipse in space is no simple task. Even the smallest movement could allow sunlight to spill around the edge of the sun, blocking the spacecraft and washing out the faint corona. The two spacecraft must maintain their alignment with millimeter precision. To achieve this, the spacecraft constantly measure and adjust their position. Their unusual orbit helps make this possible. Instead of staying close to Earth, Proba 3 follows a highly elongated orbit, reaching more than 60,000 kilometers above the planet. As the spacecraft climb higher, they slow down, allowing each artificial eclipse to last for up to 6 hours. Nature gives us just a few precious minutes. Proba 3 extends that moment into hours. And it shows that sometimes the best way to reveal something hidden is to create a little darkness.
That sounds like a fantastic mission. And to find out more about it, we have the project scientist for Proba 3, Miho Janvier. Thank you so much for joining us.
Thank you.
Now, this technology from that video sounds quite groundbreaking. How challenging is it?
Yeah, it is actually quite challenging. And actually, the mission itself is called a demonstration, a technology demonstration. I would say that it's even more than that. It's like setting the blueprint for future formation flying of two spacecraft. Because yes, this mission doesn't only have one spacecraft, it has two. And it's really tried to get those two spacecraft to fly in millimetric precision formation together. So why do we do Proba 3 for eclipses? Well, just because one spacecraft is going to act like an artificial moon and is going to cover the disk of the sun, like the moon does naturally, and the other spacecraft is going to have on board a telescope, what we call a coronagraph, that is going to image the atmosphere of the sun. But now, the reason why this is really groundbreaking for us as scientists is that other missions such as Solar Orbiter or SOHO have on board coronagraphs as well. But because it's only one spacecraft, we're really limited in terms of the size and the optical design that we have with this coronagraph.
So you can only go so far away with an arm. It's like a selfie stick almost.
Exactly. And we can't, because of the optical design, we have some diffraction of light from the sun's atmosphere, which means that we can indeed image the sun's atmosphere, but much further away from the sun's surface. Proba 3 is almost as good as a natural total solar eclipse. So we can image the atmosphere, the corona, up to from 70,000 kilometers from above the surface of the sun. And this is absolutely groundbreaking.
Yes. So yes, and I suppose because we're looking at that space weather and how these things develop, looking closer to the surface gives us an understanding and perhaps better predictability for the future.
Yes, I think what is key really to understand is like, why do we want to get so close to the surface of the sun? Is really we're trying to get to the birth of the solar wind, this stream of particles that comes from the sun's atmosphere. We're also trying to understand how little fluctuations that are happening in this atmosphere will eventually propagate outside. And something maybe that our public might not know is that we actually on planet Earth base in the solar wind constantly. The solar wind really extends all the way to the frontiers of the solar system.
Yeah, beyond the planets.
Beyond the planets, in a big, giant magnetic bubble that we call the heliosphere.
Yes.
And everything that happens in the sun's atmosphere will eventually be felt in the space surrounding of Earth. But what we call space weather that you have told earlier.
Yes, perfect. So now, it's one of the things that you were able to do was you actually got your team together to take an image of the sun from Proba 3, and I think we've got that image here today.
Yes, indeed.
So this is the image.
This is the latest image that we have from ASICS, which is the coronagraph on Proba 3. And really kudos to the team, because the amount of work and effort, they've been working through the night, literally, to get this image. As I think you can see, maybe not on the image, but normally at the bottom, it says that we started the observation at 5:20 Universal Time. And what is fascinating with this image is that this is what you're going to see later during the totality. And what you can see really is the sun's atmosphere is completely non-homogeneous. You have parts that are a little bit brighter than others, you have darker regions, and these are really related to the structure of the sun's atmosphere due to its magnetic field. And it informs us on, is the magnetic field open or closed in those regions that are brighter, so close in brighter regions, darker in open regions, which are the sources of what we call the slow or fast solar wind. And we're literally trying to get science out of this, but everyone on the path of totality can look at that only during totality, without glasses and with the naked eye.
Yes, they have to do it, but do it safely.
Do it safely, please. Yes.
But thank you, and a big shout out to the team for putting all that effort in and showing us.
Yes.
So thank you so much for sharing this with us. And yes, and we will be seeing the total solar eclipse for ourselves quite shortly.
Yes.
But thank you for joining us today.
Thank you.
Thank you. So creating artificial solar eclipses does sound like the stuff of science fiction, but we are doing it here and now. But more than a century ago, a total solar eclipse transformed our knowledge of how the universe works. And we have a video to show how that happened.
Sometimes the biggest discoveries happen in moments of darkness. On 29 May 1919, a total solar eclipse gave scientists a brief window to look beyond the sun and into the very fabric of the universe. What they found would change physics forever. In 1915, Albert Einstein proposed one of the most extraordinary ideas in the history of science, the general theory of relativity. For centuries, our understanding of gravity was built on Isaac Newton's laws. They explained why apples fall, why the moon orbits the Earth, and why the planets circle the sun. But Einstein believed there was a deeper explanation. According to Newton, gravity is an invisible force that acts between objects, no matter how far apart they are. But Einstein wondered, if light takes time to travel across space, shouldn't gravity take time too? Einstein's answer was revolutionary. Gravity isn't an invisible force pulling objects together. It's the shape of space and time itself. Imagine placing a heavy ball on a stretched sheet. The surface bends beneath its weight. Smaller objects naturally follow the curves it creates. In much the same way, Einstein suggested that the sun warps the fabric of space-time, guiding the motion of planets and even light itself. Einstein predicted that light from distant stars would bend as it passed close to the sun. From Earth, that star would appear slightly out of position. The effect would be tiny and, under normal circumstances, impossible to observe. The sun's light hides the background stars from view. Only a total solar eclipse could reveal them, and in 1919, that opportunity arrived. British astronomer Arthur Eddington and his team photographed the stars surrounding the eclipsed sun in Príncipe and Brazil. For just a few minutes, daylight gave way to darkness. After carefully analyzing the photographs, the astronomers found what Einstein had predicted. The stars had shifted. Their light had been bent by the sun's gravity. The results made headlines around the world. Almost overnight, Einstein became one of the most famous scientists in history. Einstein's theory and the 1919 solar eclipse were just the beginning. They transformed our understanding of gravity and laid the foundations for modern astronomy. They opened the door to discoveries ranging from black holes to gravitational waves, ripples in space-time itself. More than a century later, we're planning to study these ripples from space.
So you have it all here. Total solar eclipses, ripples in the space-time continuum. And it's all about gravity. And someone who's been working on the detection of gravitational waves is Martin Hewitson. Now, what is your current role?
Yes, I'm working at ESA on the LISA mission, and I'm the performance manager. So I work in the project team where the team overseeing the building of the 3 satellites that form the LISA mission.
Yes. So tell me more. Well, first of all, let's start with the fundamentals. What is a gravitational wave?
What is a gravitational wave? Yeah, so we heard a little hint of that in the video that just played, but in fact, one of the other predictions of Einstein's theory was that if you accelerate large masses in the universe, for example, black holes, then these will make ripples in space-time which will travel out from the black hole across the universe and eventually arrive here at Earth, where we can detect them with our technologies.
Lovely. And so, what I like about gravitational waves, because Einstein made this prediction over 100 years ago,
That's right.
and it took about 100 years for us to get the
Indeed.
first detection. Now, that first detection was on the ground, but now with LISA,
Yeah.
we're going up there.
That's true. And there's a good reason to do that, because in fact, similar to as we do for electromagnetic waves and for observing stars in the universe in different color bands using X-rays and infrared, we can do the same thing with gravitational waves. And there we're looking at really different masses of systems. Here, with the LIGO observations that you mentioned in 2015, we're looking at objects merging together which are tens of times the size of our sun, something of this scale. And with that, we do that with kilometer scale detectors here on Earth. But if we want to get masses similar to those at the core of galaxies in the universe,
supermassive black holes. I
supermassive
just love
black
saying it.
holes, you just like to say that word. So this is something like 1 million times more mass. Then we need our detectors to be at roughly 1 million times bigger, and that's
Wow.
pretty hard to do on Earth. So you need lots of space, and we go to space to do that. Yeah.
So how does the technology of LISA work? How does it actually make these detections?
Yeah, so we have to measure really tiny changes in the distance between distant objects. So we place 3 satellites in orbit around the sun in a way that they form a constellation, a triangle, and we use laser beams to measure these tiny changes in distance between the satellites, and from this we can extract information about the origins of those gravitational waves.
Now, things you say it as well, we just do this. But I mean, this is the stuff of mind-boggling science.
That's
I mean,
true, that's
looking at gravitational wave detection on the ground is hard enough. But we are talking, now I need to try and get the proportions right, because you're talking about a picometer.
We talk about measuring resolutions of picometers
Yes.
over these 1 million kilometer
Yes.
distances. Yeah.
And just to put that into context, a picometer, if you take an atom and slice it up probably 100
times, something like this scale. Yeah.
That's the distance we're talking about. And you're talking about measuring that over millions of kilometers.
That's right.
And so the challenge of that, is it overwhelming?
It's a little bit scary. No, but we know how to do these things. I mean, there's been a huge team of people across the world working on the technologies and the techniques for this for quite a few decades now. And so we can't see the light at the end of the tunnel yet, but we're definitely in the tunnel and we are building the satellites and
When we
getting
go round
ready
the
to
corner. Yes.
exactly getting ready to launch these 3 satellites that make this constellation.
Yes.
In about 9 years from now. So,
Okay, perfect.
yeah.
So we have time. And also,
We have a lot to do in those 9 years.
but also I remember when we were making the first detections on the ground, it
Yeah.
seemed impossible, and we did it. So I think space will go the same way, and we'll get
That's right.
amazing.
And we'll find all sorts of new things that perhaps we'd never thought of.
Yes.
You know?
It was
It's
open new windows to the
It's
universe.
really a new window on the universe. We say this a lot, it's a bit of a cliche, but it's sort of true.
Yes. Well, thank you so much for joining us, and
was a
very good
pleasure.
luck with the mission.
Okay, thank you.
Thank you. Okay, so now what we're going to do is going to go to a live feed from Lyon, because I can actually see the light is actually changing here. It's feeling quite exciting. And yes, here in Lyon, who actually get totality before us, we can see that that chunk of the cookie has really been nibbled now, and so we've got a large chunk sort of that has come out of the sun here, and that is the moon moving across the sky and blocking out that sunlight. And here we have Palenthea as well. And now with Palenthea, they're using a sort sort of a different sort of telescope. And also, when we actually get to totality, we should see the corona in glorious detail. So this is a wonderful opportunity to see both. And also, I believe we have telescopes here as well, who will be actually looking at the total solar eclipse. So we have these 3 feeds, which will be showing us the eclipse in amazing detail. So exciting times ahead. And so, what we're going to be doing now is actually, well, I'm very excited to be joined again by Carol. You're going to be experiencing the eclipse.
I am, Maggie, and actually I have been already. I've had a sneak peek. For those people who've just joined us, we're here in Ravalambre Observatory, where we will soon be observing the total solar eclipse here ourselves. And offset, I was lucky just to use very safely some of our safety glasses to see that the eclipse has already started. So as you say, yeah, so I did have a sneak peek. So it's really going to happen here. And it's not just through the live feed, we're actually seeing it here, and our teams are all seeing it here too.
But as we stand here, it does feel as if the light is changing.
It really does, Maggie. I mean, the sun is setting, but it was very bright just, 10 minutes ago. And already, as you say, it's slightly odd. It's bright, but not bright. It's a really unusual feeling.
And things are sharp.
They are
As
sharp.
I'm seeing you almost more clearly.
I'm starting to look at the shadows, and those shadows should sharpen up as we start to reduce the amount of sunlight. Of course, not looking yet with the naked eye. We have to wait for totality.
Yes. And so, we have those 3 live feeds. And so we've seen the totality. We've seen what's happening in Lyon. We've seen what's happening in Palencia. And yes, we'll be getting back to what's happening here too. But of course, with all of these things, we have to have safety first.
Always.
Yes. And so, although we're getting excited, and many of you who might have just joined, do go out but watch the total solar eclipse safely. And here we have a few tips to enable you to do that.
Before you look up, here's the most important thing to remember. Never look directly at the sun without certified eclipse glasses or a proper solar filter. Ordinary sunglasses are not safe. Even when only a tiny part of the sun is visible, its light is still strong enough to permanently damage your eyesight. As the moon slowly moves across the sun, keep your eclipse glasses on. Then comes totality. When the sun is completely covered and its corona appears, it's safe to remove your glasses and experience the eclipse with your own eyes. But only for those precious moments. As soon as the first bright flash of sunlight returns, the famous diamond ring effect, look away and put your eclipse glasses back on immediately. Protect your eyes, watch safely, and enjoy one of nature's most extraordinary spectacles.
So please do watch the total solar eclipse safely. But because we are in this special location and we have 2 live feeds, I think it's time to see how things are developing in Lyon. So let's go and see there.
Wow.
Yes.
It's really covering, isn't it, Maggie? You can see the moon. They're now starting to just see almost a crescent of the sun. So
yes,
it's really happening.
It's funny because looking at that image, coming alive from Lyon, it looks like the moon.
It does look like a crescent moon, exactly.
Yes,
it's actually
a warm moon, but it is actually the sun, and that is the moon. It's sort of blocking out
its view.
Yes. So we're getting the live now. The path of totality is quite amazing because it does actually sort of travel across the Earth, and now we can see sort of Lyon and compare it with Palencia. So yes, we've got both of those on the screen, and it's quite interesting to see how it's developing.
That's right. Of course, Palencia, we have that special telescope as well, so we can see the corona. And I know the people there, all the public who have gathered, and particularly at Lyon. I mean, we have many thousands of people there who I'm sure all have their solar eclipse glasses on, and will be seeing the same feed that we're seeing. They'll be seeing that on the sky. And in fact, as you were saying, this cookie that gets nibbled at the beginning, it starts to move quite quickly. These are big chunks now.
And it's funny, that's one of the things that does surprise me. It does move quite fast.
It really does, yeah.
And I suppose when you see the sun setting, it does move quite fast.
That's right. Once you get towards the horizon, then,
yes,
exactly.
It's a fun way. But we're seeing that here. And yes, we're seeing it from 2 different telescopes. So this is Palencia.
Yeah.
And when we get to totality, this one will be really good to see.
That will give us the coronograph. Exactly.
Yes, because we'll be able to see the corona.
Coronograph, the corona.
Yes, because it has a coronagraph, and so we'll be able to see the corona.
In fact, it's the moon acting like a coronagraph in the natural world. So,
and I think during this eclipse, Miko was talking about getting as close to the sun as possible.
That's right.
Because of this cosmic coincidence, this is the closest we can get to the sun's surface, seeing that corona from as close to the sun's surface as possible.
That's right, exactly, because the moon is really filling
Yes.
that disk. There'll be times when it won't, and it'll be an annular eclipse. So that's as close as we can get. Really fantastic.
So yes, one of the things that is quite interesting is we are bringing people together from all around the world, and I do love that.
Yeah.
That's one of the powers of astronomy for me, that people across the world can see a similar event all at the same time. So it unites us all, and I think often we need that.
Absolutely.
But we have a video message from someone who's seeing the eclipse from a very, very different viewpoint. And so this is ESA astronaut Sophie Ardeno, I think that's correct. Ardeno. And she is seeing it from 400 kilometers above sea level from the International Space Station.
Hi everyone, hello from space, from the International Space Station. And here we are orbiting the Earth 400 kilometers above your heads. And what we like to see in here is that this planet is beautiful. It is so beautiful. And it's all connected. It's just one shared home. And you know what? Today, millions of people are sharing the same experience. You will be looking up together as the moon passes in front of the sun. From here, we see 16 sunrises and 16 sunsets every day. And I must say that it's a beautiful reminder of the clockwork of our solar system. So wherever you are, if you're in Europe or on another continent, I just wanted you to enjoy, to stay curious, and I'm sending you a ton of good vibes for the solar eclipse from space.
Okay. So the light is dimming. It's
Yeah.
getting very exciting.
It's very uncanny here, I have to say.
Yes, so this is
You
your
really
first-
feel it. It's
yeah.
my first, yeah.
But do you feel that it does look strange?
Cooling. It's a very, as you say, it's a cooler light. It's kind of bright like a diamond in the sky, but it's not like the sun at sunset.
No.
And it really is remarkable. I didn't expect to actually feel it before the totality. So yeah, it's really exciting.
And so also here we've got the live feed. I think this is from Palencia. Oh, actually, no, this looks like Lyon. So we've got the live feed here. We've got the live feed coming in.
Oh, it's from
no,
here.
This is actually from here, our location. So we have a group of telescopes actually here looking at the total solar eclipse as we do.
Right behind us, yeah.
Which is lovely because we have all these telescopes in the different locations.
Yeah.
But I think Spain is experiencing this because they haven't had a total solar eclipse for some time.
That's right. You said at the beginning, since 1912 on the Iberian Peninsula. And of course, we're going to be very lucky in Spain over the next 2 years because actually we will also have a total solar eclipse next August, 2027. It'll be longer. It'll last for about 6 minutes of totality.
I'm coming back to that.
Yeah, I think we'll all make a date on that one. It's just travelling across the southern tip of Spain, north of Africa. And then the following year, we'll also have an annular eclipse. So it won't be a full total eclipse,
Yes.
but we'll see the bright rings.
Yeah, the ring of fire.
But 3 altogether. It's,
Just like
pretty
buses.
special.
They all come along at once.
And then we have to wait till I think 2053 before Spain gets its next total eclipse. So we should make the most of the next 3 years.
Yes. But yeah, usually it's if you stay in one location, it's 400 years between solar eclipses.
That's right. And as we were saying earlier on, the path of totality is very narrow. It's just a couple of hundred kilometres. And so that shadow cutting across the surface of the Earth, most of that will be on the ocean. I mean, the ocean's four-fifths of the planet. And so actually to be in a place where we can have this experience is really fantastic. And of course, as we've seen from the telescopes here, we now have Lyon, we have Palencia, and of course our viewers will also be able to see what we're experiencing, which I'm hoping we'll have a nice tranquil moment just to experience it through our glasses and then our eyes.
I think because I think it is almost like a moment of contemplation.
Absolutely,
That you take in the wonder of the universe.
Yes. I'm really excited. I'm a little bit nervous as well. I'm glad I've got an experienced eclipse observer with me, Maggie. Thanks for being by my side.
Oh, my eclipse buddy.
Exactly.
Yes. So yeah, exciting times, and we are sort of ramping up. And as we see, so yes, what's really interesting is that shadow of the moon as it travels across the Earth. And so, Lyon, Palencia, and us here, we are kilometers apart, many hundreds of kilometers apart, but it happens within about 2 minutes. Totality there, totality in Palencia, and then totality here. So it's all quite thick and fast, and so it is going to be exciting.
Yeah, you get that sense of pace, and we'll see the feeds, and then very quickly we'll be doing this for ourselves.
Yes. And so, so it's quite nice to explore because, as we're getting closer, so we're about 10 minutes out.
Yeah.
And now we're actually starting to see really some of the effects of the total solar eclipse.
Absolutely.
So we've talked about this soft light.
Yeah.
And it's really hard, I think, to describe.
I think it's impossible to
Because
describe.
sort of looking at the landscape, the shadows seem quite sharp. Things aren't quite right.
Yeah.
And yes, I am getting a
It
little...
is cooler, absolutely.
Which is a welcome relief.
Yeah.
And this is, the view from up here at the telescope. And so, yes, and so we've got 2 telescopes. And one, I think, has got a H-alpha filter, which is a very, very narrow band filter.
That's right.
But the other one has effectively a pair of solar...
so see what we will see, yes.
You know,
Yeah.
so see exactly what we will see. So that's very lovely to
And
see.
as you say, Maggie, I think that H-alpha filter is quite special. As we've said, you must only view the sun through your Mylar glasses, your special eclipse glasses, or if you have a solar telescope with a filter. So H-alpha actually measures the light that comes from the hydrogen atoms that are burning through nuclear fusion in the sun. So we actually get to do some physics as well.
Okay. Physics is everywhere.
Absolutely.
And so now, as we're approaching, so we've got sort of about 9.5 minutes out.
That's right.
And so now, we've definitely seen that temperature. Now, my first eclipse, I actually went to Le Havre, and I got one of the last ferries, and I just ended up in a field. And again, it was that magic of many, many different people coming together. But one of the things there was because we were sort of, down at sea level, the birds started to roost. Because I think when the light gets like this, nature starts to
react,
Yeah, they think, well, it's a bit
What's
early, but
happening?
it's nighttime.
As you say, the cooling temperature, the diminishing light levels, that's sending a signal to nature that it's time to take refuge. And even if it's only for a minute and a half, they take that signal. And we don't have many birds up here at the top of the mountain. But we're feeling the cooling and the dimming light.
Yes, and it was quite funny because the birds sort of all roosted, so okay, we're settled for the night. And then, hey, hold it,
Time to wake up again.
So that's all.
Very confusing.
And so so it's going to be wonderful to experience. We actually also have a few questions.
Yes.
Yes, and so I thought I might throw one of those in. I think we've just about got a time.
Let's do that.
Yes. So these were questions that were actually thrown in or sort of submitted in. And one of the questions is, with the moon moving away from us, how long will we still have the glory and the sort of cosmic coincidence of a total solar eclipse?
Yeah, well, it's a really good question. And just to explain to viewers what's happening as our Earth is orbiting around the sun and the moon is orbiting around the Earth, it's gradually increasing its orbital distance away from us. And so what that means, it will be smaller in the sky, and so actually won't block out the sun. But we have about 250 million years before that's a problem, so I don't think we should worry too much.
So our ancestors will be able to enjoy it.
Yeah.
And also, you do get different types of eclipses.
Yes.
Because as the moon goes around the sun, sometimes, as the moon goes around us, sometimes it's closer, sometimes it's further away.
That's right.
So that's how you get the annular eclipses, or eclipses that block out more of the corona.
Exactly, and I think that aphelion and perihelion, I mean, that is something, obviously, because the moon is on an elliptical orbit, that's cyclical. So that's not that we'll never see a total solar eclipse again. That's what, there'll be times when we will, when we won't, but that 250 million year time scale is that the moon just won't be close enough to give us a solar eclipse anywhere.
Yes. So what are we seeing? So we've got 7 minutes out until us. So actually, it would be nice to go back to the live feeds now and see.
Oh wow!
Gosh. So this is Lyon.
Getting very close in
They
Lyon.
are getting very close to totality. And it's going to be bang, bang, bang. They go into totality, then Palencia, then us.
We have to be ready. I wonder how everybody's feeling there. It's Palencia, wow.
Yes. And I'm really looking forward to seeing the coronagraph at work in Palencia, because hopefully we'll be able to see that corona.
Actually see the corona itself.
Yes.
Fantastic.
And Miho was telling us things that we can actually look out for. They're filaments coming off. And sometimes they're actually coloured like sort of red filaments.
That'll be amazing to see, yeah. I mean, out here, of course, we have still the bright light of the dimming sun.
Yes.
And so I think our scientists will also be analysing those images in slower time. So I'm sure there'll be many, many images that will be published after tonight.
Yeah. Yes. And even though we're close to totality, please do keep your safety spectacles on, because even in this diminished light, the light can still damage your eyes. And so watch the total solar eclipse, but do watch it safely.
Absolutely.
And yes, if you're in the path of totality, remember, keep your solar spectacles on until you actually go into totality, and then it's time to take them off. So yeah, as your first eclipse, is it living up to expectations?
Oh, it really is. And we were talking earlier, weren't we, Maggie, about what to expect. And you were saying, how will you feel? I was like, I don't really know, but I'm quite cold. I mean, it's really chilly. I mean, no, we're at the top of the mountain, but it's been a really hot day here today. And the light is eerie.
I know.
It really is.
I think there's no
strange.
way to it. I don't know if you're seeing this on film, but it's bright, but not somehow.
It's almost like electric light in the sky. It's really...
And yeah, we're getting very close to totality now. So hopefully we can actually watch this as the moon sort of creeps across the sun. But yes, it is very, very close now.
And I'm wondering what it feels like in Leon. I mean, we believe there are maybe over 10,000 people there. So we have obviously our colleagues here at the top of the mountain, but to be with 10,000 other people.
Yes.
Experiencing this together. Here we
and there
go
they
now.
are. And I think it is a moment of sort of a quiet contemplation.
Yeah.
Because the excitement of, get your glasses, get everything ready. But as it approaches, a hush. And things, I always think that people of old, this has blown their minds. What is going on? It sort of freaks out the birds. But if you don't actually know what's happening.
Absolutely,
Oh
yeah.
my
The sun has
goodness.
disappeared. What does that mean for ancient people?
Yes.
It's your harvest, it's your light. I mean, it must have been terrifying.
Yes.
And then equally terrifying when the sun comes back again.
Yes. And so now I think we'll hopefully see some of those effects. So as the moon sort of encroaches completely over the sun's surface, hopefully we'll see that diamond ring effect.
Hopefully, yeah.
So we'll see it in Leon first, and then we'll hopefully see it in Palencia, and then of course we'll hopefully see it here too.
And Maggie, also, I'm hoping that we might see, as we heard on the video earlier on, this phenomena called Bailey's beads,
Yes.
and where the light will leak past the little dips. So obviously the surface of the moon isn't entirely smooth. We have mountains, we have craters, so we may even see a little glimpse. It's like a little string of bright dots as we go into totality. So that would be
I
amazing.
always call myself a self-certified lunatic, so anything that shows me the moon in more detail is music
We're
to
up
my
for it.
heart.
Yeah, absolutely.
And my goodness, it's almost disappeared.
Almost there. And now it's much darker here. I mean, we can feel it dark here. We can see the tiny little edge of the sun still visible at the edge of the moon.
Yes. And so, as I say, it will start in Lyon, then we'll go to Palencia and see. So we're going to have, you don't just get one, you get three total solar eclipses.
Good value for money tonight on our feed. 3 solar eclipses, plus our space ones.
Yes. And
Look
so
at
there
that.
it is, just that pink, tiniest crescent of the sun.
I think we're going to be speechless. Our job is to speak through this, but
I know.
it's just
But it's quite a dark screen, so I'm hoping we'll be able to see, the Bailey's beads.
there it goes.
Yeah.
So I think in Leon they've
Almost.
taken their glasses off and
Oh,
they
yes.
must be experiencing it.
Yeah, so now I just see a blank screen because I think with the
Sun's
filters
gone.
on.
Yeah, the
yes,
sun's gone.
and they are in totality. So, and so, but compare that with Palencia. So I love this, the journey of that shadow.
Yeah.
Okay, so there's
Oh,
Leo
my
in
goodness
totality,
me.
and
Look,
there's
you can see the
Palencia.
flower, you can see the...
Oh my goodness!
goodness.
Yes, of course, because this is
Yeah,
with
yeah.
the coronagraph. Oh my goodness!
And this is Leon, and you can see it bottom left corner there, Maggie.
Yeah,
Solar
is that-
prominence, yeah.
Yes.
I wasn't expecting to see something as stunning as that.
Wow.
That really is special.
But imagine a crowd of 10,000 people looking
Now
at
you can
that.
see it in Palencia. You see the prominence there on the left-hand side?
Yes. So material being thrown off the
That's
sun's
right.
surface into space.
That is spectacular.
Oh,
Absolutely
gosh.
spectacular. I hope everybody who's watching it in both of those places are enjoying it as much as we are.
Also,
It's
it is
darkening,
getting
isn't
quite
it?
dark.
It's very eerie.
And so we're about 2.5 minutes
2.5
away
minutes
from
out.
totality here. So yes, and Palencia
has totality.
Yes, what I'm hoping to see is actually the coronagraph. So I think they have to wait till the moon is totally covering the sun, and then here it comes.
There it goes. Oh my goodness me.
So it's funny. My heart skips a beat.
I know, me too.
Because you think as scientists, but we still get that emotional
This is live.
response.
This is happening live now in our sky. Look at that. Spectacular.
Hundreds of people, maybe thousands of people are also witnessing.
And seeing that for
this.
the first time, you see that prominence there. We would not have known that was there without this eclipse. I mean,
Yes.
we wouldn't have been able to see that against the bright disk of the
Because
sun.
it's so bright.
Yeah. And even some wisps down at the bottom right-hand corner there, if you look.
And I think we were talking earlier, I think we're at a solar maxima in the 11-year cycle.
That's right, yes.
So
It's
that's
very
why we
active.
get
Yeah, the sun's
these
very active.
Oh my. But it's getting mighty dark here too.
Now I'm getting nervous, now I'm getting excited. We're a minute and a half out from
Yes.
totality here. Palencia has that. You
yes.
see, we're in the dark.
I
You
know.
see?
Actually, just
we have
literally
lights. We have electric lights lighting us. Background's dark. Sun's almost gone.
So yeah, we're about a minute to totality. So I think it is time to put our solar
I'm going
specs
to
on.
follow your lead as my Eclipse buddy,
So what I'm going to do
Maggie.
is put them on here and then turn around and look at the sun. So you're going to disappear. And so what we're going to do is step over here and actually check it out.
I'm going to walk with you.
But yeah, we're similar. So yeah, I'm looking, but I'm going to put my hand on here.
On the fence so we don't... Oh, my.
Are you safe?
I can see. I'm safe. I'm right by you, and I can see this tiny little red crescent to the left.
The thing is, this is real. This is this is space.
And I can't wait till we have totality. So we're probably, a minute away now?
Yes, I think probably less than a minute.
And it's been good, actually, to see what's happened in Leon and Palencia, because it's given us a bit of practice.
Yeah, a sneak
for this,
preview
exactly,
of what's to come.
To know what to expect.
But also built up the anticipation.
Yeah, you can see it now darkening.
Yes. And it's funny, because
Is it my imagination, or do I see Bailey's beads?
Actually, yes, because I can see some detail.
I can see detail.
Yes.
With our naked eye.
But it's funny, I haven't seen the diamond ring effect.
I haven't,
That sort of flare.
No, that's right.
But we might see it on the way out.
We might. Tiny little
gosh.
fragment left.
Yes.
I'm going to follow your lead.
Yeah.
That's it.
Okay.
Glasses off. Yeah?
Okay. Done. Oh my goodness.
God.
Oh. I'm sorry, it freaks me out. It's just
can't believe-
amazing. And I think I can see that that flare.
Yeah, I can see the flare.
Thing is,
I
what?
actually don't have words.
Oh.
Oh my.
Oh.
God. It's incredible. And this
And Venus.
Venus as well. Venus appearing.
Gosh. I mean, it just makes.
I really have no words. I mean, you were right. It's profound and moving, and I can't process it. I don't know what I'm looking at. We've talked about it for 2 hours. It's just incredible.
And it's funny when we were caught up in all the preparation.
Yeah.
But to see it.
And it's not through a telescope. It's on the sky, above the mountains here, above the trees.
Yes.
I can see why the birds nest.
Yes. And it just feels magical.
It does feel magical. And thanks to science, we know it's not magic.
I know
and
it's
we're not
magic.
scared. And then
It's magic until you know what's behind it.
until you know what's behind it. What's behind it is our sun.
Yes.
And I'm
yes.
thinking when
our
we...
local star. Oh.
It's really beautiful. So you can see that prominence. It's really red against the yellow filaments. I wasn't expecting that at all.
But also, it's the extent of the corona, even just with a visible eye.
You can see the triangular shadow kind of down towards 7 o'clock. The spikes up at the top, and here it comes.
Oh gosh! Yeah. Oh my God!
That's our diamond ring again.
Yes.
Oh my goodness.
Oh.
And
It
we're
is
safe back with
glorious.
our glasses on. Really stunningly
Oh my,
beautiful.
that
And now, that's it. And then we start to see the little crescent reappear
Yes.
as the moon, as you said before, moves on its way.
Yes. Yeah. So it just boggles my mind. It so does.
I think boggles the mind, sums it up beautifully. And now we see the light underneath our glasses, like daylight's returning.
Yes. It's getting back to normal. Still, the strange view.
light. So shall we turn away and take our glasses off?
Yes.
I'll follow you.
I've turned away and take the glasses off, and so we can see where we're going. It's funny, after I saw my first total solar eclipse, I saw it and then I had to sit down.
I feel the same.
Yes.
I mean, now the light's returning. Well, over to you to speak while I have a speechless moment.
And so that was amazing, and thank you for everybody who's shared that with us. It has been sort of quite mind-boggling for me, and so that's my third eclipse, but I'm still
and different
emotional.
to the other two. I mean,
yes, actually seeing it, it wasn't as low on the horizon as I thought it might be.
Same for me. It's a little higher than I expected.
Yes, but the detail of it.
Yeah, the detail's incredible.
Yes, and seeing that sort of prominence coming out as a sort of distinctly red.
Very red.
I didn't know you'd be able to see that with the naked eye.
No, I didn't. I thought that would be with filters, maybe the telescope has the resolution,
But to see it with the naked eye, and that is...
Absolutely. It definitely deserves a round of applause at least. And maybe some champagne.
We salute you.
And I think, as you said, Maggie, in this stunning valley, I mean, we're looking out across the fir trees, the mountains. Earlier on today, we had cloud and haze,
Yes.
and we weren't sure what we would have. And then this eerie nighttime light is what it feels like. But
Yes.
it's not nighttime.
The nighttime, but bright and
bright,
sharp and
yeah.
crisp.
Oh my goodness. I forgot to look at the shadows because I was too busy looking at the eclipse.
I think that probably makes sense.
I think you might have now set my family holidays for a decade. I think I'm going to become an eclipse chaser. No, really very, very special.
So yes, I hope you were able to share that with us. But gosh, actually, what we are getting here now is, I think, the live feed from right here, but with the telescope.
That's right. Yeah.
And seeing the thing is, because it's a cosmic coincidence. Yes. But the sun and the moon, they don't care.
They
it just
carry
moves
on
on
their
its
way.
way.
Absolutely, it's orbital dynamics.
the shadow passes and it's gone. But it's been lovely being here and being able to see it happen in Lyon, happen in Palencia, and then happening right here, right behind us.
Absolutely, Maggie. And I think, what I would like to say is, first of all, a huge thanks to the observatory here at Alhambra for having us, because this has been such a special place. A thank you to all of our wonderful speakers who've explained what we're about to see, what it meant, and prepared us for that, which I don't think we could have been better prepared for.
No, because it's nice having the view and the knowledge as well.
It's not just an experience, but actually understanding what we were looking at. Incredible thanks to all the ESA teams, obviously ESA Web TV, our ESAC teams up in Madrid who provided the telescope feeds, and of course to our ESA Science Communication team who've worked tirelessly for months to bring this to us. And when things move smoothly, there's a team of very dedicated people behind. But last but very not least, a very special thank you to you, Maggie, for being my Eclipse buddy, for being an incredible host of this live stream. I know many, many people online have been watching this, for being such a warm and generous host, and for actually sharing your passion, not just for solar eclipses, but for science, for astronomy, for the technology that delivers this to us, and for keeping me company there as I got a bit wobbly emotionally, not wobbly by the fence, but just emotional at this incredible experience. So thank you.
But thank you. I cannot think of a better eclipse buddy, so thank you so much.
Thank you, Maggie.
Now, our transmission is ending now because as the moon moves on in the sky, but you can see the rest of the eclipse. Please go to ESA Television, where that will be available. And of course, this isn't the end. I mean, ESA has got so many other missions out there. So next, I think one of ESA missions is Bepi Colombo. So yes.
That's right. So actually, we've been seeing the sun, but of course, when you go out to the sun, it's a very hostile environment. So Bepi Colombo is our brave little mission that's been flying out into that hostile environment near the sun. And in September, the spacecraft will go into orbit of Mercury, be captured by the gravitational pull, and then before Christmas, we'll release 2 spacecraft with our Japanese colleagues and our European colleagues to study the physics and the science of this incredibly interesting rocky body that lives so close to the sun and actually has done some little eclipses of the sun itself. Very hostile environment for our spacecraft, but the teams have done a great job. 8 years journey to get there. So,
the culmination.
Yeah.
So watch this space. And I think now we're going to be joined by the rest of the team, all our wonderful experts that have guided us through this fantastic event.
Come enjoy,
so I think, cheer. So solar science, it's happening here. Thank you so much for joining us at home. And do keep on watching the eclipse. Go to ESA TV to see it there. Thank you.
Thank you.